video is a quick how-to instruction build video of how to construct this linear actuator. This is the threaded rod or linear rod. Mostly I'm just using a threaded rod design. So this one's much slower moving, but it has a lot more strength. So it's really probably too slow for most robot designs, but it could be used to lift pretty heavy weights. So how this is basically print these 3D parts. The coupling is not a clamping coupling like is used in the rack and pinion, but is a set screw coupling, because this is using a metric 8 threaded rod, and so the metric 8 coupling I have happens to be a set screw kind, not the clamping. Both work. So basically there's an embedded metric 8 nut. You want to push that in. I find that some needle nose pliers and maybe a hammer or a screwdriver and a hammer can do that pretty well. This one's pretty loose. In fact, it's so loose I think you may just be able to push it in, figure my neurons, with your hand. Then thread in the, you can use a drill to thread this very quickly into this plastic case. Okay, then this thing goes into this case, this 3D printed case. Right, and then into this coupling. Then you will tighten this coupling. I use, I think these are either metric 3 or metric 4, they look like. Countersunk screws, and then very tightly, it has to be pretty tightly to clamp onto that rod. You can even maybe grind the rod flat to make it a little bit better. Then close the top, and 2 metric 3 screws are then used to tighten that on completely. And there you go, very simple.